Okay, we're on.
Wait.
So, number 1. What are the 3 chemical components of a nucleotide?
Right. One.
I got I got 1 to 3 phosphate groups
Okay.
for one of them. And then the pentose sugar.
Mm-hmm.
So 2 deoxyribose for DNA and then a ribose for RNA. Then the nitrogen bases, the pyrimidines, DNA, cytosine, thymine, adenine, and guanine, and then for RNA, cytosine, uracil, adenine, and guanine.
Perfect.
Yep.
Okay, so 1' carbon. I said that the nitrogen bases attach at this point.
Mm-hmm.
At this area.
Yep.
So then 2' carbon.
Yep, that would.
Go for it.
That one's attached to the 2 hydrogen atoms in DNA, or a hydroxyl group and a hydrogen atom in RNA.
Perfect.
It's connected to the 2.
What?
Can you guys hear me?
A little bit.
Little.
All right.
Okay, so 3'.
It's important for
I'm not hearing anybody.
DNA.
And
He's gone.
So I said it was important for like the attachment of phosphate groups because this is where the hydroxyl group is at the end, and then so it is able to form that bond to create that phosphodiester linkage.
Yeah.
yeah.
And then everyone got the same on that?
Can you?
Okay, so 4' carbon.
That one's basically just structure.
Yeah, just to help the ribose and deoxyribose.
That one was so hard. I was like, what?
Didn't make any sense to me at first.
I was just like, what? I had the hardest time finding the answer, and I'm like, oh, you know what? It's so simple that it's hard.
Can you all hear me now?
Yes.
Yeah, better.
Better.
All right.
Yeah.
So 4' carbon.
It's connected to a phosphate group and is used in DNA RNA synthesis.
Beautiful. Love it. Okay, number 2. Anyway, so we have, I put down cytosine, uracil, adenine, and guanine.
That's what I thought. But we got it wrong.
Oh, nucleotides. That's what's wrong. I totally see what I did wrong. It's you have to use that stupid whatever name, just kind of like with all the whole thing.
It is adenosine and guanosine. Those names?
Yeah, but they have to be connected. Since it's a nucleotide, it's connected to a phosphate too. So you have to call it like guanosine triphosphate or
phosphate
for all
something
of those.
stupid.
Yeah, it just has to be something phosphate.
Interesting.
Yeah,
Yeah,
and when
so
it's a nucleotide, it's that third form. But yeah.
Oh, and then the next one's nucleoside. So that's you just don't have to add the whatever it's called, the phosphate group to it. It would be like a something.
Yeah, I mean, It said for some reason because it's DNA, it has the deoxy in front of it.
Mm-hmm.
So all of them are deoxy, guanosine, adenosine. But
Yeah.
yeah, but yeah, that's how those ones are. I got confused on
Bond,
that. I forgot about the deoxy thing.
sugar.
Okay, so what do you guys put for C? C for 2?
I got guanine and cytosine at 26%.
I got the same.
Oh no, where'd he go?
Well, and 0% uracil.
I got that. For your cell is 0%, and then adenine is 24%.
Yeah.
Adenine. Okay, so D. What'd you guys get for D?
RNA.
It's RNA, yeah.
It's RNA, and I said it's also single-stranded.
That's what I put.
Oh, yep, that would make sense too.
Yeah, well, most RNA is single-stranded.
Because RNA is all single-stranded. But
There's very few.
Well, it could be double-stranded in viruses.
is it double-stranded? I don't remember.
It can be.
Yeah, viruses can be, but this one's a single-stranded virus.
RNA is normally single-stranded.
RNA is
That does sometimes
typically.
become.
Okay, so 3A. What'd you guys get for that one?
All right. Got
I can't hear what you're saying, Richard.
approximately 1.2 million.
I did not get that.
Yeah, not for A. Yeah, A was 0.067 meters.
I got that.
Yeah.
Sorry, 1.2 meters is what I got.
Yeah, but it's still 0.067. What did you do?
It's on right here.
It's 100. Oh, can y'all hear me?
It's cutting in and out.
I don't know what the deal is. You guys should be. Well, anyways, I have 6 times 10 to the negative 9th times 197 million.
You didn't put in the conversion factor of the base pairs to nanometers because one base pair equals 0.34 nanometers.
I went looking up to find it because I couldn't find anything in the reading.
It's kind of in the PowerPoint. If you go to slide number 10, and it gives you the distance between one nucleotide or one base pairing, which is 0.34 nanometers. And so you use that. So you convert one base pair to nanometers, and then nanometers into meters.
That would explain why I got about twice as much on that.
Yeah.
I have 6 nanometers.
Okay. So do you want to go to number B? Or 3B?
Mm-hmm.
I got a range.
Number 3, my lord, pick number 3.
So on B, I got a range between about 1.3 million and 1.34 million and almost 1.35 million.
I think that's what I got. I did whatever scientific notation, so I have to think for a second.
Yeah, I got
Oh,
1.01 times 10 to the 6.
yeah, a million, about.
Yeah.
Yeah, I think I got the same because I got 1. Yeah, 1 to the 10 to the 6. Oh, yeah,
Mhm.
I think a million. Yep.
1.22.
Okay, so C
One.
got
Go for it.
1.224 times 10 to the 8th 8 histones.
Yeah. That's what I got.
Yeah. Yep, same.
Excellent.
I got 1.63 to 1.64 times 10 to the 8th.
Okay, let's see. You did the conversion of one nucleosome to base pair, right? To the 196 base pairs.
That were listed on your guys' that page is not the one that was on my instructor does it. Mine said 146 to 147 base pairs.
Yeah, but you have to add the extra 50 base pair whatever in each linker too. So that's where the
I
196 or
didn't
197
understand the
comes from.
linkers at all. I
It
thought that was
talks
just
about it a little bit in the reading, but
I thought that was just extra information in the question because it didn't seem like that had anything to do with the question.
oh, yeah, because each nucleosome has a linker between it too. So for every nucleosome
There's
that
8
has,
histones.
yeah, so it's like the base pairs plus the linker for every single one that you have to add it up or whatever. So that's why you add the 50.
Okay, that would make much more sense on that number, but I didn't catch that in the reading anywhere.
Okay, so D.
Well,
I got 6.12 times 10 to the 7 H3 molecule.
Yep.
Got that.
Yep.
Awesome. Okay, so we're moving on to 4A.
I'm pretty sure that's because they didn't get the same numbers as y'all and everything else.
Yeah, probably. Okay, for A, that one is guanine, uracil, and thymine.
Yeah.
Not all. They're all in the nitrogenous bases.
Okay, so then B is adenosine.
Yeah.
Adenosine, yeah. Adenosine.
Guanosine, cytidine, uridine, and adenosine triphosphate.
Yes.
Yeah, I got all that. And then nucleosides.
Nucleosides, adenosine, deoxythymidine, uridine, and guanosine.
And cytidine.
And then the nucleotides.
Deoxycytidine monophosphate.
Perfect.
ATP.
Mm-hmm.
And the one that I know is not, I don't think it's real, deoxyuridine diphosphate.
Oh, yeah.
That
Yeah.
it couldn't be deoxy if it was on
If it was a
uridine.
Oh
uracil,
my
yeah.
gosh. Oh
That's
my
funny.
goodness, that's so big.
I didn't even notice. I did it
Me
really
neither.
fast.
Oh my goodness. That slipped under.
That's funny.
Okay, so 5.
5 prime means the number 5 carbon in the deoxyribose sugar that is connected to one phosphate and designates the place from where DNA replication starts in adding nitrogenous bases.
Yeah, and attached to the adenine.
Okay, so it's the start point.
Above it.
We got that.
Yep.
On B, I got for 3' means the number 3 carbon in a deoxyribose sugar that connects the sugar to the phosphate group on a different nucleotide.
It has a free hydroxide on it.
Yeah, because it's the end. If the 3' is the end of it, then yeah, there's a free hydroxyl group on the end.
Okay.
That's what I put.
Does anyone want to give out C, or are we pretty sure that we know the opposite of the letters?
Yeah, I
I
think
think we're pretty good on that.
Yeah, we just need to make sure that we started on 5 on the one side,
And
it's also, that's where the 3 on
Yeah.
yeah.
prime TACBTGG.
Yep.
okay.
And then D and the DNA double helix.
I thought that there was 2.5 turns.
Yeah.
Same.
Because there's 25 base pairs on this chain, but there's 10 base pairs on an original regular DNA double helix. So you do the 25 divided by the 10.
Yeah.
I got
Okay.
this. I got 2.5.
Yay!
Perfect.
We're good. Does anyone have any other questions?
It's open this weekend, right?
Yeah, the test is this
Yeah.
weekend.
We have a test.
Yep.
Yeah. I didn't know that till Tuesday.
So are we all good?
We good? Time for next week? Just want to. Oh, I have something at 7 o'clock.
I'm good whenever.
I think I'm good. I'll have to double check with my schedule. It just hasn't been posted yet.
Okay. I have my meeting at 7 this week. So.
Okay.
So we're doing 6:30, 8:30. What are we doing?
Let's do 8.
8.
Yeah.
All right. See y'all at 8 next week. Good luck on
Okay,
the
we'll do.
Sounds good. All right.
Okay.
Bye.